Welcome to eDNA Tech. In the previous videos, I have used a keyword named volatile. Why I used the keyword volatile and what is the use of the keyword volatile? So I am going to explain about the volatile in this video. So before that, we need to know what is a code optimization. So in this you can see they have mentioned a snippet with a code int x is equal to 0, and they have written a main function, and they are checking whether if x is equal to 0 print x is equal to 0, or else print x is not equal to 0. In this video, in this page you can see the else part will be optimized because x will never other than 0. So here you can see the x will be never changed unless until you are going to change it physically. So the x will be not changed means that if x is equal to 0 condition will always satisfies. So only this condition will be satisfied, and the compiler thinks this will never perform and it will optimize this else function. So here you can see the same function is written with the help of volatile. They are using a keyword named called volatile, and they have declared x is equal to 0 here, and they is going to check if x is equal to 0, print up x is equal to 0, else print x is equal to not equal to 0. Here the code will never optimize because we have declared a keyword called volatile. In this, the volatile comes to know volatile. If you are using to use the keyword volatile means the compiler comes to know that this variable can change at any point of time. So it will also check if this function, if x is equal to 0 is performed, then it also check the variable named x, and whether it satisfies or dissatisfies the if condition, and it also perform else. So it will never optimize this else function. So let me explain this when we are going to use in the peripheral. So they have given an example. They are going to use a register with the value 0x1234. This is the address of the register that they are going to use. It is like a status register. So if wait for the registers to become non-zero, that means the register will become first, initially the register will have a 0 value, some value. So when the register changes from 0 to 1, that means other than 0, non-zero, so we should wait until the register changes to 0. So if this line is written, this will be converted to assembly line like this. First they are moving the address of the function that you are written here will move to the pointer. So this pointer will be moved to the whatever the value that is stored will be moved to the accumulator, and this while loop is converted to loop branch loop. That means it will run until it will go at as a infinite loop. So if you are going, if it doesn't, you are using the volatile in front of the data type, so it will optimize these lines. So it will not check whether the value of ptr is changed, so it will go infinitely. If you are going to use a volatile in front of the keyword, so here you can see the difference between the volatile and the code that contains volatile and that doesn't. So if you are using the volatile, the assembly of for the above line will be like this. So it will move the address to the pointer, and then the compiler will give a address that is accumulator. So you the whatever the value that is stored in the pointer will be stored in the accumulator. Then the loop will run to the accumulator, and it will keep on checking the value. When the value changes, the loop will terminate. So we need like this. So when we are going to change the value in between, likewise if the flag register becomes 1 because of the external device, then so we are going to wait until that. If you doesn't use volatile in front of these functions, then you are going to lose that point. So you are going to lose the, it will never check whether the flag is 0 or 1. It will goes on infinitely. So for the compiler not to optimize your code, you should use a volatile. So I am going to explain this with our Arduino. So yeah, I am going to use two LEDs. Now my aim is to glow a LED alternatively. First this LED, next this LED, and keep on blinking likewise 1 2 1 2 1 2. So for that I am going to use the port D, and I have written a code here. You can see there is a while loop, and I am going to write here output for the pin 2 and 0x08 for pin 3. So I am keep on alternatively changing with the help of while loop, and I have introduced a delay function in between to see our function. So it will become fast, so it keeps on running and we cannot see. So I have introduced a delay, and in that delay I used a keyword called volatile. So here you can see the difference, how how this function performs while we simulating with volatile and without volatile. First we are going to run with the volatile. So here you can see the bulb glows alternatively. When I remove this keyword volatile from my program, you will see the difference. They are no alternatively glowing, they are stable. That things, the I is 0 initially and it doesn't changes. So this void delay function completed only once, only I equal to 0, that's it. It moves on to the other line. So it doesn't runs for a particular amount of time that I written here. I have written I equal to 0 to 1 lakh times. So it only runs for I equal to 0, and then it will optimize this code. So for your compiler not to optimize your code, you should use a volatile in front of your data. So here you can see the difference before volatile and after volatile. Before volatile, the LEDs will glow constantly, and here you can see with the help of volatile it will show glow alternatively. This is the use of volatile in the hardware or embedded C, and you can name it anywhere, but this is the basic usage of volatile. So whenever you are going to deal with registers and their address, better use volatile. So you cannot know when the value will be changed or when the values of the registers will be changed, it is unpredictable. So you can use volatile in that area. So that's it for the functions of volatiles, and you can see it, and we will see in the next video how to interface the push buttons and LED in the same Arduino UNO. See you in the next